Hello everyone, I am Professor Amit Vyas, Computer IT Department from Dr. Subhash Technical Campus. Today we are discuss about unit number 9, the introduction to NP Completeness. So now we can discuss what is the class P problems and NP problems. So the class P problems and NP problems. We can say that the algorithm is solved given the problems in the polynomial time. If the worst case is running time of the algorithm is belong to big omega of P of n, when the P of n is a polynomial, then n is indicate the problem of size. So what is the class P problems? We can say that the algorithm is solved in the polynomial time. It is called the class P problem. Also, the problems is solved the worst case of the running time, also called the polynomial. So then next, what is the trackable and intrackable? If the problem is solved in the polynomial time, it is called the trackable problems. The problems which cannot be solved in the polynomial time, it is called the intrackable. So this is the two types, trackable and intrackable. Now we can classify the what is the P problems. The problems are set of the problems that can be solved in the polynomial time of the deterministic algorithm. P problems can easy to solve and easy to verify. So what is the P problems? Problems can be solved in the polynomial time or within a deterministic time of algorithm, and P problems can be solved easy and easy to verify that. For example, that P problems are searching some element of the array, sorting the selection sort, finding the height of the tree, sort the data using merge sort for complexities n log n. So this is the all the problems. It is called the P problems. There exist many important problems. All the solution is not found in the polynomial time. So far, not has to been proved the solution does not exist. For example, TCP, graph coloring, next step problems. It is called the which is the not solved of the polynomial time. So next we can show the NP problems. So we can show the what is the P problems. Mostly P problems is solved the polynomial time or deterministic algorithm. NP problems. NP problems is mostly solved the non-deterministic time or we require the more time. So we can show that the NP problems are such the problems that can be solved in the non-deterministic polynomial time. NP does not mean a non-polynomial. It stands for the non-deterministic polynomial time. So what is the NP problems? NP problems, you can say that the non-deterministic polynomial time. If the time is required to more compared to the polynomial, so it is called the NP problems. But it not means it is the not solve the all the problems of the NP problems. So this is the main difference. First is what is the P problems? The P problems mostly solve the polynomial time. What is the NP problems? NP problems mostly solved in the non-deterministic polynomial time, but it is does not mean it is the not solve the all the problems. So this is the problems we can show that. So this is the NP class. You have checked that this is the problems you have defined. First of all, the problems. Problems we have two parts: P class and NP class. And then we can show that the NP class have two types: NP complete and NP hard. So initial condition, the problems is defined, which is the P problems. It means polynomial problems or non-polynomial problems. Then after it is defined NP complete problem or NP hard problem. So this is the main structure of the polynomial problems. Now, what is the NP completeness problem? We can show that what is the P problems and NP problems. We can show that here the P problems is mostly problems that the solution can be solved in the polynomial time. It is called the P problem. So what is the P problems? The problems are set of problems that can be solved in the some polynomial deterministic algorithm easily. It is called the P problems. And now what is the NP problems? NP problems are the problems that can be solved in the non-deterministic polynomial time. It is required the more time compared to the polynomial. It is called the non-deterministic polynomial time. And NP, it means does not means the non-polynomial, for it stands for the non-deterministic time. So this is the importance. Now, so this is the basic class. You have saw that this is the problems and then P class and NP class. Then NP class is derived into two parts for the NP completeness and NP hard. Now, what is the NP completeness? We can show that if the any NP complete problem is belong to class P, then P equal to NP. So you have said that if any NP complete problems is belong to class P, it means NP complete problems is belong to class P, then it is belongs to P equal to NP. So if any NP completeness problems, these problems is any mostly same algorithm is required for the P problems, then you have said that P equal to NP. Every other problems in the NP can be transformed from the P polynomial time. So every NP problems can be solved in the polynomial time mostly. However, the solution of the any NP complete problem can be verified in the polynomial time but cannot be obtained in the polynomial time. So we can say that the mostly NP complete problems can be verified the polynomial time, but it is not sure that is the polynomial time. NP complete problems are offered to solve the randomization algorithm. So this is the NP completeness problem. Solve the well-known the NP complete problems are listed here. So this is the mostly solved the NP complete problem. So Boolean satisfy problems and next step, traveling salesman problems, subset sum problems, vertex cover problems, Hamilton path problems. So mostly these types of problems it is required to more for the P problems and it is complete the NP complete problems. So you have saw that the next step problems also P polynomial times you have solved that, but it is required to more complex than it is required the NP completeness problems. The traveling salesman problems is also called the NP hard problems in the many times, but it also called the NP complete problems. So this is the well-known NP complete problems is listed. Now we can show the NP hard problems. We can check that this is the NP complete problem. Then now next we can show the NP hard problem. NP hard is a superset of all the problems. It means the NP hard problem are at least the hardest problem in the NP. If we can solve the NP hardest problem of the polynomial time, we should be able to solve all the problems is NP problems in the polynomial time. So we can say that if the every problems is solved of the polynomial time, so NP hard problems is always solved the polynomial. Then second we can say that, so we can repeat that if the every problems is solved the polynomial time, then NP hard problem is solved that these problems of the polynomial time. So this is the importance. So we can say that to solve the any NP hard problem on the polynomial time, we would be able to solve all the problems in the NP problems of the polynomial time. NP hard problems does not have to be NP. Even they may have not decision problems. So this is the NP hard problems. Subset of subproblems, traveling salesman problems are NPC is also belong to NP hard problems. There are certain problems which is belong to NP hard, but they are not be NP complete problem. A well-known example of the NP hard problem is heading problems. Many example is NP problems is belong to NP hard problems. So we can show that the different mathematical given the different relationship consider the following possibility. If the P equal to NP and P is not equal to NP, the relationship between P, NP, NP completeness and NP hard is shown in figure. So we can show that this is the one polynomial problems, this is the NP problems, this is the NP hard problems, and NP complete problems. It is mostly also in the solved in the NP problems. It means the polynomial time. So if the P equal to NP, otherwise NP complete problems is NP hard problems. So this is the importance. We can say that if the every problems, if any problems is solved in the NP hard, then P problems is solved there. So we can check that the NP complete and NP hard comparison. The NP complete problems are decision problems. NP hard problems might not be decision problems. NP complete problems is harder problems, and then NP hard problems is a hardest problem. NP complete problems is NP. NP hard problems is not belongs to NP. Three set problems. This is one example, and heading problems. This is one example. So now this is the comparison of the NP hard and NP complete problems. So this is the importance. So this is the problems of the NP hard and NP completeness. We can revise that. So here the class have a types P class or NP class. In the NP class have two types, NP completeness and NP hard. So first of all we can show that what is the polynomial problems, what is the P problems. P called the polynomial problems. It is the solve in the polynomial time. It is called the trackable problems. And NP problems. The problems cannot be solved the polynomial times. It is called the intractable problems. But what is the actual P problems? The P problems, it is said to solve the problems in the polynomial time and deterministic algorithm. It is called the P problems. P problems can be easy to solve and easy to verify. For example, some searching algorithm, sorting algorithm. So this is the P problems. And now what is the NP problems? NP problems such that it is solved the non-deterministic polynomial time. It means it is not solved in the particular time duration. But it does not mean that it is the not polynomial. You can say that it is the solve the problems, but it is required to more time for the efficient manner. It is called the NP problems. So now this is the main difference of the P problems and NP problems, or P class and NP class. Now we can say that in the NP class have two types, NP complete problems and NP hard problems. So what is the NP completeness problem? If the NP complete problems, it is mostly solved in the P time duration. It means polynomial time. So you have said that P equal to NP. So you can say that every problem is solved the polynomial. So this is the NP complete problems. Now this is the example of the NP complete problems. Next step problems, traveling salesman problems. This is the NP complete problem. Now what is the NP hard problems? NP hard is a super set of problems of the every class problem. Superset. It means you can say that if the any problems it is solved the NP hard problems, then it is required some time duration. Or you can say that if the every problems or any problems it is said that some polynomial time, non-polynomial time, or NP complete problems, then it is always be solved the NP hard problems. This is the NP hard problems. So this is the relation of the different mathematical formula. The polynomial problems. Then NP problems have said that the NP completeness problems is mostly in the solve the polynomial time or either NP hard time. So this is the structure, and this is the comparison of the NP hard and NP complete problems. Now we can say that the traveling salesman problems. So traveling salesman problems. TSP is belong to class of problems is computational complexity analysis called the NP complete problems. If you could find the way to solve NP complete problems is quickly, then you could use the algorithm to solve all the NP problems quickly. The time of required to solve the problems using NP problems is any currently knowledge of algorithm is increased very quickly as of size of problem of growth. So what is the TSP problems application and what is the dependency? The TSP have server application even is purchased some formulation, some planning, logistic, manufacturing of the microchip. Silently modification you have applied appear some subset of problems of many area, such some DNA sequencing. So city representation of the customer, soldering points and DNA fingerprints. Distance you have measured the TSP problems, traveling time or cost, similarity measurement of DNA fragmentation. So what is the traveling salesman problem? The TSP problems is mostly used of the many times for the particular networks or particular area. TSP mostly in the particular NP complete problems or NP hard problems. Many times the problems is solved in particular time duration or otherwise the problems is not solved in particular time duration. So the TSP problems, it is identify some city, some area or some distance also. So mostly used for the logistic and application analysis, traveling time and all the particular area. So this is the example you have traveled for a particular distance. They have not required particular direction. Suppose here distance is given from A to B, B to C, C to D and D to A. And how can you travel and you have covered the minimum cost of the particular distance and solve the problems. So you can say that A to B is only one path, so you have the distance is 25 cost. But B to D, you have directly go B to D, then cost or time duration is 45. For cost, you have said that this is one cost, the cost is maximum. But you have go to the B to C, and then after you go to C to D, then cost is 50. So this is the basic algorithm and functionality logistic apply of the TSP problems. And then after, if you go for the D2, so now you have checked that the sequence is A, B, C, D, and then after you have directly go to the D2A. So this is the basic requirement or logistic you have applied. So this is the importance. If you go for A to D, also you have go so directly A to D, or otherwise you go to the A, C and D. So this is the importance of the logistic of the TSP problems. So now the traveling salesman problems is the more for the complex problems, research, analysis problems for the distance, time and manufacturing. So this is the TSP problems. Now we can show the Hamilton problems. Undirected graph G equal to V comma E or V belongs to E is called the Hamilton if there exists the cycle which cover all the vertices in the V exactly once the expected starting of the vertices as shown in the figure. So this is the diagram. Hamilton problem. Hamilton path is formulated by removing one edge from the Hamilton cycle, Hamilton path, visit every vertex in the graph, but does not form the cycle. So here, the importance. So what is the Hamilton path? It is remove one edge from the Hamilton cycle and visit all the vertices but not create a cycle. To construct the Hamilton cycle from the Hamilton path is required adding the one edge. So we can say that the Hamilton path it is construct the one tree and then it is remove from edges but not create a cycle. So here you can say that if it remove one connection of the edges but the cycle is not created, here the input of the graph you have so that here this is the points you have connected all the, but this is the output of the Hamilton problems. You have checked that here the one point you have starting and then finally completed particular cycles. So this is the Hamilton problems. This is some examples of the Hamilton dimension of the example of the Hamilton. So now we can refer all the problems of the TSP problems, NP complete problems, NP hard problems, and all the functionality Hamilton problems here. So here you can solve all the Hamilton problems, and you have saw that this is an example. This is one create one points, the number of points you have created particular cycle base, but this is the problems of the Hamilton. So here also Hamilton problems you have solved that. So thank you all of you.